Hello everybody and welcome back to Environmental Science 101. This time we cover soil, right? So soil is going to be tremendously important for human life, for the ecological world, for plants, for everything. And so we're not going to use this word dirt. It's done. It's demeaning. We're not going to use it. We're going to call it soil from now on. Okay, awesome. Soil, this stuff, right? Going to be our uppermost layer of the earth. Full of living things and essential for all life. You scrape off the top 2 feet of this and something really bad happens to human beings. It's porous, right? Meaning air can travel through it. Not, totally, you know what I mean, right? Gases can travel through it in some capacity. It's got little holes like a sponge is porous, right? And water can travel through it. It's got little particles of air and water, as we'll see. Holds on to, right? Lots of water and nutrients for our plants. And it filters and breaks down waste and does other important things like nitrogen fixing, right? So what is soil actually made of? What's in there? Well, it's going to be a mix of things, right? We got our bedrock particles and minerals, right? So we got broken down little pieces of rock and individual minerals. We got air, we got water, and then finally we got our, organic matter, right? Most of which is dead, some of which is alive. Okay, so let's break it down. So about 50% of it, a little under, right? 45% is going to be mineral particles. You can imagine these as being little tiny rocks, right? 25% air, including all of the gases in air, which we might remember is what? Nitrogen, right? Oxygen, carbon dioxide. 25% water, and then 5% of it is going to be organic matter, though it's a very important 5%. And of that 5%, 80% of it is going to be this thing called humus that, if you imagine going to Home Depot and buying a big bag of potting soil and you open it up and stick your head in, right? Okay, that's humus. That's what we should picture. 10% is going to be plant roots, and then other is going to be living organisms. But most of the organic matter, right, all but this last 20%, it's going to be dead and decaying, nice, really rich stuff with lots of nutrients. That is good, right? Soils, right, have this kind of composition, but they also have certain textures, right? So what we're really looking at is the size of the individual particles and, how much we have of one size compared to another. So there's going to be 3 main terms here. You got sand, silt, and clay. Right, so sand, we know something about, going to be millimeter scale stuff, but we should know silt is going to be maybe 1/10 as big as sand, and then clay is going to be 1/10 as big as silt. So much smaller particles there. Something we can also clarify just while we're here. If this is confusing, then forget it. Clay can refer to particle size of things that are really small, and it can also refer to a type of mineral when we say clay minerals. Awesome. So the best soils, right, tend to be things that have a mix of all 3. Some sand, some clay, some silt. We call these loam or loamy soils. Now, not every plant is going to grow best in this, but this is going to be the best soil broadly. Absolutely. It's got enough clay, it's clayey enough to where it holds on to moisture, right, that the plants can pull out. They don't dry out, but at the same time, we need it sandy enough that water can pass through it, right? It has to remain porous. We don't want it to clog up, right, or get stiff. And our loams, if we go over to our handy chart, right, are going to be very roughly speaking kind of in the middle, right? A mixture of all 3. As far as how to read this chart, if it's not clear, then we don't really need to know this, but we have 3 different directions, right? So here's 100% clay, 100% sand, 100% silt, right? So if we start here, right, what we essentially have is what? Some percentage of silt, 50%, right? And some percentage of sand, 50%. And how much clay do we have right here? Would be 0. So we've got 3 different directions, 3 different axes here in our triangle chart. If we don't know how to read these, that's okay. What we need to remember, loam has a mixture, and that's the best soil. Awesome. Layers. So soil, right, we think about the top layer, right? But it's going to depend on how far down we are, right? And this is all going to be considered soil, right? Some people call these layers, some people call them horizons. Both is fine, right? But we got these things that are broad, flat, kind of thin, but extend really far in terms of area in all directions. I've got a picture here of what it would look like, and then I've got our diagram for the different layers. So we've got our top layer, right, which, as we see, just the very topmost, like, couple inches, right? It's going to be our O layer. O stands for organic, right? We got living stuff up here, some of which, a lot of which, is undecayed, right? And tons of organic matter, tons of that humus stuff. Our A, right, is going to be this thing we call topsoil. Tends to be really rich, fertile, good. We want a lot of topsoil. Here, right, we have down to 10 inches. That's really going to depend on where you are, but about a foot is a good measurement. B is going to be subsoil, right? So ignore this for now, right? What does that mean, subsoil? It means it's still going to be closer to soil than it is to rock, but not quite as much as our topsoil. So it's still soil, but it's a little bit rockier, right, than the really good stuff. Below our B layer, our subsoil, is going to be the C layer. Stratum just means layer, right? So we got a sublayer. And here is where we get to the point where it's more rocks, right, and rock pieces than it is soil, as opposed to, right, our B layer, still more soil than rock. And then finally, if you keep going all the way down, we get to the R layer. R stands for rock. So here we got hard rock, tough. If you imagine, you know, a slab of concrete down here, that's not really correct, but it's probably the right mental image. And we can go, right, back and forth between our real picture and our horizons, right? So our top, maybe 2 inches, right, our O would be somewhere in here, right? We've got our topsoil all the way down about here, a little bit below where it is on our diagram. Our subsoil here, right? Stuff leaches down from the layers above that's not so great, but still more soil than not. Might say that this part of it here, all of it, right, is our substratum, which is slowly actually becoming soil over time, but is more rock than soil. And then down here, we got our bedrock, solid, hard stuff, hard to use. So we've got our different layers, and now we can talk about how these layers come to be, right, how they form. So there are 4 steps to this. We don't need to know every single detail along the way. We don't even need to know that there's 4 steps, right? We just need to have this general idea in mind. So we've got rock at first, right? Imagining our slab of concrete, not the worst thing to imagine. It's subjected to the elements and stuff that's trying to grow in it and break it up, and it gets all these cracks, right? And it starts to break down and react with water, react with air, get messed with by living organisms, and it starts to break down into simpler parts molecularly, right? Simpler stuff that is better for all the plants and animals to use, right? So it gets broken down and stuff is living in it and dying in it and putting waste products into it and doing all the other stuff that life does, right? But here, right, it's just our bedrock and a big old sea horizon, more rock than it is soil. Over time, right, it keeps weathering in the face of the elements, in the face of all this life, which is living in it and dying in it and putting its lifey, gooey products into it, right? We start to develop all of these layers. So, undeveloped, right, totally rock. We're developing, slowly getting more and more soil at the top, all the way developed, right? We've got our distinct horizons. Some places are going to weather faster than others, right? And we say weathering, what we're talking about is breaking it down, both physically and chemically. Awesome. So formed by weathering and exposure to the elements and to life. It gets broken down by water and by organisms. There are going to be 5 things that influence the formation of the soil. This is really not critical stuff for us to remember, but let's go through it real quick. We got our parent material, so some rocks break down easier than others, right? Lava rock is going to break down really well. Other stuff might be tougher. Granite might be a little tougher. Topography, right? Do we have hills, valleys, mountains, whatever? Climate, right? So wetter and warmer means it's going to break down faster. You got more water, and at warmer temperatures, these reactions are going to happen at faster speeds. You're going to have more life as well to break it down. The types of organisms, whether it's sparse or whether we have a lot of worms and plants, and how much time, right? More time means more time to break down the soil. Awesome. Finally, we can apply this to our soils here in Arizona, right? So we have these things that are called aridosols, right? So arid means dry, right? Like a dry desert. And sol just means soil. So literally just dry soil. This is going to be typical of deserts really throughout the world, although this is kind of a US term, right? We can see our distribution. So all through Nevada, what we might call the American West or Southwest. And we could maybe be really clever here and realize that there's almost like this dividing line, right? Where we got desert stuff on this side and non-desert stuff on the other that will come back. Tends to have low organic matter, right? So if we were to look at one of these, we don't necessarily see that big, well-developed O layer, something I maybe could have mentioned, right? So we don't always get all of those layers. Sometimes we do with really great soils, right? But sometimes we don't. Tends to be water deficient. We knew that. Dry. Tends to form very slowly because we don't have a lot of water or as much life as other areas, and really varies in thickness, right? So our soil thickness here throughout the valley going to range anywhere from 18 inches to 2 feet on the low end, all the way up to about 20 feet at the max. Just to contrast this, right? How far do you have to go down to get to groundwater? For the most part, it's going to be hundreds of feet, way lower. And that is part of what determines how the life here can develop, right? And what it needs to survive. So that is going to be everything on soil. The next part is going to be on soil pollution and the ways that this can be mismanaged.